So double angle, half angle. And I was on and reduction formulas. Guess I'll pause for the formula part. Okay. So again, on the top, sine of double angle, sine of 2 theta, only works for only has one form. Although this doesn't have to be just a 2. It could be like 4 or 8. You can just say, well, you know what, that's just 2 times something. You can always break it up or force a 2. Most of the time, forcing the 2 will not be helpful. But if you see an even number in here, then yeah, write it as 2 something. Okay. Cosine 2 theta, same idea. Although you have 3 things to choose from, choose the one that you think is most useful or helpful. It's up to you. Depends on the question. And then, of course, there's tan 2 theta. It's only one. And as I said before, the location of the half angle will determine if this is plus or minus. So let's say we know that. Let's do the cosine. We know cosine is negative in quadrant 2, right? So if we had, let's say, cosine of 120, let's say theta was 120, half of that would be what, 60. So that location would be positive. 60 would be positive, which would be plus. But the angle itself is negative essentially. Does that make sense how you think about it? So the one in here would actually be negative, but the one out here would be plus. Because cosine of 120 would be minus.
Could be plus and 60. But then you don't know it's gonna be positive.
Well, the result would be negative. What's cosine of 120? It'll be 1 plus that negative value, right? 120 is, let's see. Yeah. Yeah, so it'd be 1 plus a negative half right there.
Oh, okay.
But over here you would choose the plus if theta is 120. But we'll do examples in a second. But just keep in mind you gotta know the quadrants. Okay. You guys cool on this page? Yeah. Right here? Yeah. Let's do an example. So example 1. Find the exact value given that tangent theta is equal to negative 3/4. And they go ahead and tell you that theta is in quadrant 2. So part A is find sine 2 theta. Part B is cosine 2 theta. C is tan 2 theta. So we're given this information here. So if we're in quadrant 2, need to know what part is negative, what part is positive. So you build a triangle using this tangent first. Having that will help you. Like we did the last example on Friday. It might have been Wednesday. So given tan theta equal to negative 3/4, we know that that is opposites. If we put theta here, it'd be opposite over adjacent, right? Now, you can also think of it in terms of the x and y, or sine and cosine. So in quadrant 2 is cosine negative. It will be, so the adjacent side will receive the negative. They don't tell you if the minus is up top or in front or on the bottom. Right? It's just negative. So you need to figure that out based on the quadrant. Is that clear? So once we know where the negative goes, well, the other one's going to be the opposite side, right? It's going to be positive. Hypotenuse is never negative, so that one's going to be positive, but we don't have it. So solve for hypotenuse. This is one of the special triangles. What do you think the hypotenuse is?
Right.
Has to be, right? And if you solve for it, it's going to be 5. Now that we have that, we can answer the questions, I think. But let's go ahead and write down the functions. We're given this, now we know that sine theta is equal to 3/5, so make that positive. Cosine theta is equal to negative 4/5. Now we have all the info to answer the questions. So let's start part A. Okay, so far still with me, right? It's okay. So sine 2 theta, use your formula. That's going to be, or your identity. Change it to this. 2 sine cosine. So if you didn't do this work before, you'd have to do it now because you need sine and you need cosine. See what I mean? Got to plug them in here. So we're going to get 2 times 3/5 times negative 4/5. That makes sense? So make sure you know where the minus goes. Okay, so that'd be 2 times that times that. What is that going to be? For sure, there's a 25 on the bottom, right? For sure, it is negative. This is technically 2/1. So it'd be 2 times 3 times 4. What is that? 24. It's not going to reduce. So we're good. So that's part A. Any questions on part A? Part B, cosine 2 theta. Now, since we found everything, you can choose whatever formula, but doesn't matter. I'm going to use, I guess, that first one. I just chose it for no reason. Doesn't matter. Cosine squared, we'll just plug in this guy and square it. Negative 4/5 squared minus 3/5 squared. Square that stuff. What do we got here? Right? There's 16 minus 9. 7, right? So I don't like numbers, so let me know if I mess it up. So 7/25, does that reduce? No. 7 is prime and 7 never goes into 25. 25 is just 5 and 5, so just stop. Any question on A or B? See, we're just using identity and plugging in the stuff we know, but you can't do anything until you assign the signs to the correct spots.
For those problems, do you like always have to draw?
That's the easiest way, in my opinion. You could use those other formats I gave you with the sine squared plus cosine squared equals 1. I think this is better.
Yeah.
But as you can see, there's no sign to choose for the double angles, right? They're just positive, doesn't matter. But if they were half angles, that's when it gets kind of weird. So I think that's the next one. Well, maybe not. There's a couple of things we're gonna do first. Yeah, let's do one of those before we get to the proofs. You guys cool on example 1? Oh, yeah, that's right. C was 10, right? Okay, what is tangent? I don't remember. It was 210 over 1 minus 10 squared, is that right? Okay. Tangent was given to us as -3/4. So this will be 2 times -3/4 over 1 minus -3/4 squared. This will become -6/4 over. Well, you know what? I don't have enough space to do that calculation. It's going to be this. You want to see the work on the board. We'll do that. Multiply this out, you get -6/4. For that guy, you get 1 minus 9/16. Right? One minus 9/16, so 16 over 16. When you get the common denominator, 16 minus 9, which that was 7/16. That'll become -6/4 times 16 over 7, right? Is that right? 2 times -3/4. So it was given to us. Yeah. 1 minus 10 squared. Be 9/16. I don't think this is right. Well, let's see. I think I messed up. Yeah, I should have just reduced it. Fine. 16 divided by 4. Gonna be 4, right? So we'll end up with -6 times 4. It's gonna be our 24. Yeah, we're good. Anyway, any question on the work? I know it's messy, but where you multiply these two. Down there, back them, fraction. So that's what happens here. You divide this fraction and it flips over. Any questions on A, B, or C? Is it all right? All right, let's do the half angle type. Yes, cool. I turn the page. Make this wait a bit. Example 2, be the same thing. Find the exact value. Given that tangent theta is equal to 8/15. And they're telling us that theta is in quadrant 3. Part A is sine of theta over 2. Part B is cosine theta over 2. C is tan of theta over 2. Now, before we do any work, we should figure out what that quadrant means and deal with that half angle stuff. Build a triangle, etc. Okay. So quadrant 3. Since theta is in quadrant 3, that basically means that it's between 180 and 270, right? That section. So that's where theta is. So they told us, where is theta over 2, the half angle? Wouldn't that just be half of everything? Just to get divided by 2 everywhere? It's half of 270. Is that 135? Does that make sense, the logic? So if theta's over here, half of it would be half the distance, right? Which quadrant is this? Yeah, it's gonna be 2. So originally we had quadrant 3 and both were negative, right? Now we're in 2, so which function is negative? Cosine will be negative. So as when we're solving sine theta over 2, cosine theta over 2, etc., we'll choose the appropriate sign based on this one. Okay. But when you find the originals, sine, cosine, whatever, you choose this one. Yes. You're gonna be based, it'll be based on the original, because we're gonna put theta inside the triangle, right? So it'd be based off this and this. So let's do that next. So tangent of theta is equal to 8/15. That means that if I choose to put theta here, opposite and adjacent are here. They should both be positive, or I guess I should say. In quadrant 3, are they both negative or positive? Yeah, they're both negative, right? You divide them, 10 becomes positive. So this is actually minus and minus. When you solve for the hypotenuse, you're going to get a 17 here. I'm going to skip that step. Another magic triangle. You want to do it, feel free. Once you have that, write down what sine is. That will be opposite. And adjacent. You guys agree? All right, now that we have all that, we can talk about, we have all the info we need to answer the questions, okay? So I know what the functions will be. I know the location of the half angle and the location of the original. So now let's just start part A. The sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine over 2. Okay, do I pick plus or minus? Yeah, we're gonna pick plus because the location of the half angle is quadrant 2, which means that sine is positive there. So I choose plus. Is that clear?
So for that, half angle.
Yeah, half angle, since I'm doing a half angle formula, the formula gives you plus or minus, and you need to choose it. And you will choose it using the location of half angle. Okay. So I'm going to choose plus, so I'm not going to write it anymore. So just plug in your cosine, which is 1 minus a negative 15/17. Okay, so that'll become, let's see, 17 over 17 plus 15 over 17 divided by 2, which gives us 32 over 17 divided by 2. It's 2 times 17. That 34. Anyway, that will reduce to 16/17. Running out of space, wrote too big. If you rationalize, I'm going to skip a step here, you'll get this. So again, we're just doing fractions, but in case you don't remember, minus becomes plus. denominator is 17, so also you get 17 changes to 17. 17 plus 15, 32. Same denominator, 2 is still there, that puts over multiplies. This reduces to 16, 7. Root of 16 is 4. You can end up with 4 over root 17 rational.
So you just want to put it to the 17.
Yeah, just 100. Okay, so if you're curious for the rationalization step, I don't have a state space there. Exclude this entire thing. You're gonna end up with 4 over root 17. Right? So we rationalize this guy by multiplying. That gives us 4 root 17 over 17. The book might, or the homework might accept this. Well, I guess for chapter 7, I'm gonna be hand grading it, so I'm cool with this one. Okay, this is more proper. It's all good. Any questions on part A? Is that okay? All right, let's do part B, on the next page. Oh no, wait a second. Are you guys cool on this page? Part B. Cosine theta over 2 is equal to plus or minus the square root of 1 plus cosine theta over 2. Should I pick plus or minus? Do you see why? Yeah, because it depends on the location of theta over 2. Where is theta over 2? Yeah, quadrant 2, right? So cosine is negative there. So you should choose negative. Okay, so now negative 1 plus cosine. What was cosine? Okay, over 2. So that gives us negative 1 minus 15/17 over 2, which will be 17 over 17 minus 15 over 17 divided by 2. That gives us 2 over 17 divided by 2, which cancels the 2, gets us to, oops, forgot my minus. Flip it over times the half, the twos will cancel. Right, square root of 1, well, that's just gone. Rationalize. We get negative square root 17 over 17. If you want to stop here, that's fine. Or this one.
Why is that 17?
Which one? Right here. Right here. So square root of 1 is going to be square root of the top.
Oh, so we have to go with those things for the 17.
Yeah, square root of 17 is square root of 17. You can't do anything. You got to rationalize it. Yeah. Yeah, it was negative the whole time. Minus. That you mistake. Any questions on cosine? Theta over 2. You see, we're just using a formula and then doing some fractions. Just make sure you understand the sine thing. Okay, it's important. Okay. I'll let you guys do the tangent. I need to get back to other topics. Okay. Example 3. Put cosine of 6x in terms of cosine 3x. So cosine of 6x, you agree, is the same as cosine times 2, 3x, right? That makes sense. So we're forcing the double angle to show up. So this is like our theta right there. So use your formula, cosine 2 theta. Well, you know, we can add an extra step, so it makes more sense. Let theta equal 3x. So now I have cosine of 2 theta equal to 2 cosine squared theta minus 1, which is equal to, right? If I let this 3x be theta, do you agree that it would turn into this? Is that clear? We had a 2, and I'm replacing 3x with theta. So I have 2 theta. Apply your formula from the notes, you get to here. But theta was made up, so change it back to x. And that's it, nothing else to do. So now I have my thing in terms of 3x. Any questions on number 3? Not too bad, right? Okay, let's move back to proofs. So the homework will start off with, for the first 2 examples, find double angles, half angles. maybe some basic stuff like this, and then it'll become proofs. Okay. No, wait a second. Okay, you guys cool on this page? All right. Prove the following. 1 plus sine of 2 theta is equal to sine theta plus cosine theta squared. I'm gonna choose the one on the right because it has a square on it. It looks harder. I don't know. Might be the same. I'm choosing over here. So that'll become sine squared theta plus 2 sine theta cosine theta plus cosine squared theta Okay. You guys cool with that distribution? Right, when you square this, you're gonna get 3 terms. Everyone see that or not? No? Square, that means you're doing this, right? Right. Square it, sine times sine. Sine squared, sine times cosine. Sine, cosine. Cosine times sine, well, that is the same thing. Cosine times cosine, base here. You end up with this. Right. We'll flat out. You end up with 2 of these. Cosines of the square. So you can think of it in many different ways. Just use a formula, right? That's what the way I like to do it. Is if I have 2 things being squared, that will always be this. This old school formula from maybe middle school, I don't remember. Want to do it that way, or just they used to call it FOIL. I think some schools use the box method. We're just multiplying. Multiply this by. But once we're there, do you see a bunch of identities? Right? If I rewrite this to make it more obvious, this is equal to what? Right? What is this? This is the one we just talked about. This will become 1 plus 2 sine theta cosine theta by the Pythagorean. This will become 1 plus, we just talked about this, that was a double angle. For sine, yeah. Sine 2 theta. This will happen by the double angle identity. And that's what we wanted to show, right? We wanted to get here. Any questions on the identities or how we got there? Is it clear? If you would have started on the left, it would have been a little harder. Well, you know what? It would have been the same. Right? You change this guy. Let's pretend we start over here. I changed that into this. I would have had that. No, it would have been hard. Never mind. It looked like it would have been easy. We chose the right side. You guys cool in 4? Okay. They may, if they don't say prove, they might say verify the following, which is the same thing. Verify that these two sides are equal. Okay. Well, you know what? Let's try. I'm gonna try it differently than the book did. I'm gonna start with the right hand side. The book started with the left, and it worked out, but I feel like I would have chosen the right if I didn't know that. The right looks more disturbing, right? All right, so subtract that denominator. This will become cosine over sine minus sine over cosine, correct? Using the ratio property or identity. Subtract those fractions. Get the common denominator, you'll end up with cosine squared over sine cosine minus sine squared over sine cosine. Dang it. And skip the fraction step. Do you see how we get here? Is that okay? So combine those two there. You'll end up with 2 over cosine squared theta minus sine squared theta over sine cosine. Okay, so that'll flip over. We'll end up with 2 sine theta cosine theta over cosine squared theta minus sine squared theta. that correct? Do you see how this will flip over and times it 2? You have fraction into minus, this will flip, and then times it 2. So this part will be at the top. Okay. So trying to set this down. At this point, I'm hoping you see double angle formulas that are triggered in your mind. What formula is at the top? Yeah, that's the sine double angle, right? What's on the bottom? 2. Yeah, so right here, we have sine 2 theta over cosine 2 theta. Using a double angle right here. Which is equal to tangent of 2 theta. Just by using the ratio. If you have sine over cosine, that is tangent. This one was a little more tricky. So the first idea we had was, you know what, let's just package if we want to did so, it's not from, and we ended up with double angle identities. Okay, is that clear what happened? So make sure you have your formulas up front, so now we have even more. So you should have a whole page by now. So put them all in one place, that way, if you need it, it's there. You don't have to be looking through everything. I'll also send you a formula sheet made by the book. If you want to use that, you can. That's cool. No questions on 5. Okay. What's time we got? Okay. One last question and we'll call it a day. Example, I think it's 6, right? Yeah. Write an exponential. Oh, sorry, an equivalent. Equivalent expression. Not containing powers greater than 1. So this is a power reducing question. If you have cosine to the 4th, reduce it until you have only powers of 1 on all your trig functions. That's what they're asking. They're just regular cosines, no cosine squareds or 4ths or 3rds. That's what they're asking. Let me write this a little better. I'll write some more details. Given cosine to the 4th, reduce the power. So you agree that cosine to the 4th is equal to cosine squared x times, or cosine squared squared. That's the same as a 4th. Do you agree? Now look at your power reducing formulas. What was a cosine squared? 1 plus cosine 2x. In our case, we have x. So see how I reduced the power. But I still have that square on there, so now you're gonna have to multiply it out and then do it again. So this will become 1 plus 2 cosine squared, I'm sorry. 1 plus 2 cosine 2x plus cosine squared 2x over 4. You multiply the top, multiply the bottom, you're gonna get this. So everything has a power of 1 on the trig functions except this guy. So you're gonna have to do the identity one more time. The fourth looks weird, so what I'm gonna do is pull out the fourth in front so we don't have to write it as much. Takes up a lot of space. You guys cool with that multiplication? Did it bother you a little bit? It's the same thing we did here. Gonna have, what do we have, 1 plus? Multiply it twice, and you end up with 1 times 1 times cosine. Cosine times 1. Cosine 2x and cosine 2x. Gets us here. So that's where this top part comes from. Okay, 2 times 2 is 4. Guys, cool with that? All right. So I'm gonna pull out the fourth. I don't want to deal with it. So I have 1 plus 2 cosine 2x. This guy needs to be reduced right here. So I'm gonna put parentheses on it. I'm working on this one here. So if I apply formulas to this guy, do you agree that it's gonna be 1 plus cosine 4x over 2? Okay, so follow me here. So pull that 4 front, now I'm going to write this big fraction part. Just pretend it's not there, it doesn't matter. Okay. 1 and 2 cosine goes right there, and apply the formula again. So what does the formula say? 1 plus cosine 2 theta. Our theta is 2x, 2 times it. It's 4. Does that make sense? So whatever theta is, you do times 2. When you apply a formula, you multiply times 2, whatever thing. That's what we did there. Times 2. You got it here. So again, times 2. Got it there. So basically the powers are being absorbed into the angles here. It's kind of cool. Let me write that a little better. Nice. You do follow me up to this point. Okay. So I pulled out the 4 just so this wouldn't look as messy. Now we're pretty much done. We did what they asked. Do we have no longer, none of them have powers greater than 1. But we have a bunch of weird terms, so let's bring the fourth back in. We're gonna get 1/4 plus 2 cosine 2x over 4. Well, you know what? Yeah, that's fine. 1/4 times 1 is this. 1/4 times that guy is this. 1/4 times this will be an 1/8. Yeah, it's a little easier to follow if you ignore the 1/4 and then bring it back.
Where did you get the 4x?
4x? That's from the formula. What does your formula say? The double angle? I think it's this, right? this correct? So whatever's in here, it's gonna double.
For a double or a half? 'Cause
It's the power reducing formulas. In the lower right, I think. I think it's right. Okay, so this is what's happening. We're reducing the power to here, right? But whatever's in here needs to be multiplied by 2 whenever you use it. Okay, so we had originally we had an X, so it became 2X. Okay, so that part makes sense, right? So then do it again. We already have a 2X, so times 2 has to be 4. Okay. Once we get there, we're just multiplying by numbers and fractions. So at this point, I mean, this is good enough, but if you want to combine into one fraction, you need an LCD of 8. So multiply everything by 2/2, these first two at least. For the amount of time, I can't show as many steps here. But you agree that you would multiply 2/2, 2/2 to get to here. Add everything together. You will get 2 plus 4 cosine 2x plus 1 plus cosine 4x over 8. 2 plus 1 is 3 plus 4 cosine 2x plus cosine 4x all over 8. This is as pretty as you're gonna get. If you stopped here, I would have been fine.
For the second, we don't multiply by 2 since it's already.
Right,
Okay.
already started there. Any questions on this example? Now let me take roll, and then we'll stop here. Sadie, Jadlyn, Ava, Andre, Zoe, Aaron, Michael, Alexandra, Juan, Juliana, Andrea, sorry, Kimberly, no. Diego, Teresa, Hunter, Angelica, Connor. All right, guys, if you have any questions, feel free to stick around. If not, I will see you Wednesday. I'll try to leave some time for homework questions on Wednesday, maybe Friday.